So it's youtube.com. Some guy, some maths YouTuber was commenting. And when you're as small as us, you got to reply to every comment. And it was solving one of these. I think it was this one. And go to the comments somewhere. Good morning.
You live?
Yeah. 4 comments. I don't know why they don't turn up sort when newest first. Okay, hold on. Oh, I gotta step away for like 1 second. Does this work? Wait. What was I talking about? Right, yeah. So I thought I would address this comment in this video and then just edit later. So, blah. Already did this one. Anyway, I was looking at this problem, consecutive number sum. Have some trouble converting my writing into train functions. I still think this solution works, but visually ... Got to go by. Cheers, Rack, for helping me, for holding my hand through all of that. Yeah. It's been invaluable. Catch you later. Be gone. Adverts. Skip. Alright, so the problem is, given a positive integer n, how many ways can we write it as a sum of consecutive positive integers? And the solution proposed is, you can write that 5 different ways, is that right? Really? Can we see what those are? We can by doing this. And instead of all of this, you look at there, and you pick out the ones where they are. So let's do this. That's the M, comma, close that. Ooh. What? What's... Oh, right, there we go. And we can see that it's apparently... Oh, sorry. 1, 2, 3, 4. 1, 2, 3, 4, and 5 makes 15. 2, 3, 4, 5, 6? No. I got 10. I got 5. Oh, 6 because I'm in quarter 0. Right, for this, let's just change it. Right, that's 50. 1 plus. 2, 3, 4, 5, 6. It's 20. That doesn't make... How many ways? Oh, is this including permutations? Yeah, it would be. Maybe. Right, as far as I can tell, this is telling us that 1, 2, 3, 4, 5 gives 15. This one is telling us that 1, 2, 3, 4, 5 gives 15. This one is telling us that 4, 5, 6. Okay, fair enough. And this one is telling us that 7, 8. Yeah, so that's 1, 2, 3, 4, 5. 4, 5, 6. Do this. 1, 2, 3, 4, 5. 4, 5, 6. 7, 8. And it claims there are 5 ways? What are the other ones? just 15. Don't know if that counts. 1, 2, 3, 4, 5. But 2 of these are the same. 0, 1, 2, 3, 4, 5. Does that count? I haven't actually looked at this, so.
Consecutive positive integers, and note that n is the
Headphones.
So let's take a look at the examples that we created. So here are 3 examples. The first one, our input n is equal to 5, and our output, the answer should be 2. And that's because we have 2 consecutive sequences that sum to 5. So the number itself is a sequence of length 1, 5.
Okay, so you get yourself.
This, and there's a sequence.
Here we go. 1, 2, 3, 4, 5. 4, 5, and 6. 7, 8. Oh, and 15 itself. Okay. So you plus slash each of them. It's always 15. That makes sense. Anywho, so that's just a bit of understanding the problem. Where were we? Alright, this guy's solution, he wants to trainify it. So Shraff from Maths Info. Blah, 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 blah. Sorry, I was hoping this would be quick so I could edit it down, cut it up, show it to Shraff, and just link it here and be like, boom, done. But I've gone on a tangent. So let's go and hurry this up. You want to know what about converting this to trains, right? So basically, it depends on what type of thing the problem is. So like, for example, I see you're doing like whole outer product and an each on here, but I would potentially convert this to rotate rank 1, 99, selfie, iota, omega. Oh, is it not? Is it? Nope. Hold on. You've got iota omega, and you want to rotate that by itself. So I want to take. Oh, is that it? Yeah, okay. So it's just a single product. So rank 099. Then you can just do a single plus scan and look for the 15s in there. Right? And then it's the same, I think it's just plus slash comma again, right? This one says 4. What have I missed? Oh, and the self. And the self, right? So you can always just add 1 plus, because the self is always going to be there. So 5 has 3 different ways, is it? That's 5, 2 and 3, and how is it saying there's 3? Oh no, I made a buggery of this. In here. It's just 2, it's just 2. So I've done something wrong. That's just 2. But if it's 15, 4. Oh, 15 is 4. Oh yeah, okay. So no, I'm just being daft. Anyway, so that's like just how I'd simplify the solution, but it is. Oops, sorry. Oh, it's called something. That is how I would simplify this. Yeah, so you're going to get performance benefits from just keeping everything flat and blah, 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 blah. But now I will look at trainifying both of them, and we'll see that I suspect they're just not good candidates for trains, and you're better off keeping them as defense. So if you take your consecutive numbers, okay, and I'll also link to dialogue.tv. I have a webinar about trains and decoding trains and when to and when to not use trains. And it's called Train Spotting in Dialogue APL. So I'll pop a link to that here, and that'll tell you everything there that you want to know. But let's just look at this specific example, right? So we can have the problem up here. Okay. So here's your solution, Shraf. And one way you generally can quickly do this is all your references to omega are going to become right tacks. The curly braces are going to become round parentheses, and then you're basically just going to count the number of functions from the right. So that becomes dyadic. So in this case, you want to enclose iota. That's one function. Dot outer product. Dot rotate is another function. Iota is the other function. So that's 3 train. Then you're doing plus / each, but that's basically a top, so that's monadic, so you need to parenthesize that. Then omega equals, so that's fine. Then comma / is monadic. Pick comma /. So you need to parenthesize this because the middle train, remember, is always dyadic. And then your pick is also monadic, so you need to parenthesize that as well. And then finally a plus /. Oh, and then let's change omega to a right tack. Okay, so that is how you trainify yours. I'm trying to look for any other. Then you kind of looking for how can I get rid of parentheses, and like with a top, that becomes one function. But we can't put in a top here, for example, because it will bind these two together before the reduction, and then you'll basically just get something wrong, like some kind of error, or just the wrong answer in this case. So you can see it's just, yeah, they're not always good candidates for it. Let's take my one, and you'll see it's probably the same. So, indeed, iota, the right tack thing. So that's one function now, right? Iota top right tack. Then the rotate rank 0.99 selfie is the second function. But that's monadic. So you have to add an extra set of parentheses there. Then plus scan is also monadic, so you need to wrap that. Although actually in this case you might be able to get away with just a little atop there. Then right tack equals, and then plus / atop comma. So we know we have basically one function. Oh no, this is one. Then so by using a top to bind, we can end up with one giant right hand function, which then so that's 1, then 2, then a 3 train, and then it's just another top overall. So for my example, we were basically able to do it. For my reworking of your solution, we were basically able to do the trainification, but kind of at the cost of readability again. Like in both cases, I would say I would have just stuck with the Beefin version as being much more readable. So it's basically a case of not everything is suitable for a train. If you want even more info and a better idea of when is and when isn't a good idea to trainify a function, then there's this webinar called Train Spotting in APL, which Train Spotting in Dialog APL, which apparently I've searched for before on